Hello class. Today we're going to talk about mean absolute deviation. The reason why we're doing this is because one of our standards says that we are to determine the mean absolute deviation and use this quantity as a measure of the average distance data are from the mean using a data set of no more than 10 data points. So in today's lesson you're going to find out that mean absolute deviation is not one of the most fun things in the world to do, and that's perfectly okay. But we do have to understand how to do it because it is one of our standards. It's a very simple three-step process. So we're going to start our lesson today with reviewing some statistical measures that you should know. So what I would like for you to do is I want you to take these 10 data points and I want you to find the mean, median, mode, and range of the data. So before I talk about what that is, I want you to pause the video and see if you can find for me the mean, median, mode, and range of this set of data. Okay, so let's find out if you did this correctly. Well, we know mean is nothing but finding the average. So we take the data points, we add them all up. In this case, we divide by 10. The median, you've got to do something with your data before you can actually find it. You have to put it in order. So you put it in order, either big to little or little to big. It makes no difference, and you find the number that's exactly in the middle. Mode is the number that occurs the most often, and range is the largest minus the smallest. So let's see if you came up with the right answers. Okay, so here is the mean. So what you're going to do is you're going to take those 10 data points, you're going to add all those numbers together, and sorry about that, I had to change my pin code there. Add up all those numbers and divide by 10. In this case, if you were to add up all of these numbers, you should end up with a sum of 816. You take that, you divide it by 10, and you end up with 81.6 as the mean. Okay, so the symbol that we use to represent the mean is X bar. So X bar is equal to 81.6. Now for the median, okay, what we have to do is we've got to put the numbers in order. Well, if you'll notice, the numbers in this data set, I have already put them in order. Now, what you've been taught back in elementary school and over at HIS is to find the median is you cross them out. And when you get into the center, the two in the center, your median is going to be in between those two. So what you've been taught is to take the 77, add the 86 to it, and divide that by 2. And if you do that, you end up with, oh, I didn't do that on my paper. So you take the 77, and we bring up our calculator here because we do have a calculator. I can get my calculator to work here. Bring this up. We do 77 plus 86, enter. We divide that by 2, enter, and you find out that your mean is, or your median is 81.5. Okay, so that's your median. Okay, so now let's find the mode. Now the mode is the number that occurs most often. So if you look at our data points, we only have 2 numbers that occurred more than any other. So our mode is actually 77. Now if we had more than one number, let's say we had another 86 in our data set, you can have more than one mode. So one mode is called unimodal data, 2 modes is called bimodal data, 3 modes is called trimodal data, and after 3 we don't care anymore. Okay? And then last but not least is our range. And our range is always going to be our big number minus our small number. And so in this case our range is 44. Okay, so the mean tells us the average of our data. The median tells us the middle of our data, where 50% is below and 50% is above. Sometimes it's not going to be one of the data points. If you have an even set of data, that means there's going to be one in the middle. It's just not going to be one of your data points. Okay? If you have an odd set of data, it will be. Mode just tells you which one repeats itself, and range just tells you how spread out your data is. So those are the statistical measures that you already know. Well, today we're going to add one to that, and that is mean absolute deviation. And mean absolute deviation is nothing but the average distance a number is from the mean of your data. That's all it amounts to. Okay, so there are 3 basic steps that we follow whenever we're going to find mean absolute deviation. The first step is we're going to find the mean of our data. Well, we just did that in our warm-up. So it's adding all your numbers together and dividing by how many numbers you have. That's going to be step number 1. Step number 2 is we're going to find the positive distance each value is from the mean. So in other words, we're going to take our data point and subtract the mean from it. Now, sometimes if you do it that way, you're going to get a negative number. But for the second part of this, what we want is the positive distance a number is from the mean. And then last but not least, we're going to find the mean of all those differences. So let's look at an example before we do one. So here's an example right here. So we've got the data sets of 3, 6, 6, 7, 8, 11, 15, and 16. Okay, so those are our data points. Okay, so what we're going to do is we're going to first find the mean of the data. So we're going to add up all these numbers here and divide by, in this case, 8, because there's 8 of them. So we've already done that here. We've taken the 3, 6, 6, 7, 8, 11, 15, 16, added that up to get 72. We divided that by 8 to get 9. Okay, so the mean of our data is 9. Then what we want to try to do is find the average distance each number is from that mean. So we take each of those points. We take the 6 and we subtract 9 from it. You take the 3 and subtract 9 from it. You take the 3 and subtract 9 from it. And so what this graphic is showing is that when I take this 3 right here, it's 9 away, or it's 6 away from that mean. And then the next number 6, it's 3 away, and 3 away, and 2 away, and 1 away, and then 2 away, 6 away, 7 away. Okay, so we do all of that. And then, so we take these distances, we add those up, we divide that by 8 again, and that gives us our mean absolute deviation. Mean absolute deviation, really, the only thing we use it for is to tell us how good our data is. If that mean absolute deviation number is a really large number, then we know our data is not very good. It's very spread out. If our mean absolute deviation number is small, then that means our data is really good and all of our data is pretty close together. So let's see if we can actually do one. So here's one that we're going to do together. Okay, so the first thing you want to do is you want to write down your data. So in this case, I'm going to write down my data. My data is 10, 7, 13, 10, and 8. Okay, so now what we want to do is we want to find the mean of that. So we're going to add those 5 numbers up, 10, 7, 13, 10, and 8. We're going to add all those up. Okay, and we're going to find the mean. Okay, so you add them up, divide by 5. In this case, our mean was 9.6. So you write that all the way down just like that. Now what we're going to do is we're going to subtract these. So we're going to do 10, take away 9.6, and you get 0.4. 7, take away 9.6, you get negative 2.6. 13 minus 9.6, you get 3.4. 10 minus 9.6, you get 0.4. And 8 minus 9.6, you get negative 1.6. Now what we want to do is take the positive value for each one of those. So this is 0.4. Well, the positive value of negative 2.6 is 2.6, and then 3.4, and then 0.4, and then 1.6. And what we're going to do then is we're now going to add those differences together. So if we were to add these differences together, we're going to get 8.4, and we're going to put that in the sum. When you see the word count, that just means how many data points did you have. In this particular one, we had 5. So we're going to take that 8.4, and we're going to divide it by 5 using our calculator, and you're going to end up with 1.68 for our mean absolute deviation. And now that tells us, because that number is a rather small one, that our data is good data, that it's all relatively close together. Now, if you remember correctly on that standard that we said, our standard way up here says it'd be no more than 10 data points. Okay, so that means we do have to practice on something with more than 10. Now, typically on the STAR test, it's going to be 5 to 6. But in Mr. Nash's class, we're going to look at 10 of them. Okay, so here is one that we're going to do. Okay, so we're going to this will be our last one that we do before you have your assignment. So the first thing I like to do when I'm doing this is I like to put my data in order. Okay, so in this particular one, when we look at the data right there, we would have 74, 75, 77, 79, 81, 82, 85, 87, 88, and 90. Now, I'm not doing this. I've already done this, pre-done this, so we can kind of move through this rather quickly. So what you're going to do is you'll take all of those numbers, add them all up on the calculator, and in this case, we're going to divide by 10 because there are 10 data points. Well, when you do that, you find out that your mean is actually going to be 81.8. So we would write that all the way down. And now what we would do is take each of our data points and subtract the mean from it. So if you do that, you end up with a negative 7.8, negative 6.8, negative 4.8, negative 2.8, negative 0.8, 0.2, 3.2, 5.2, 6.2, and 8.2. Now we take the positive difference of each one of those. So that negative 7.8 turns into a 7.8, and then 6.8, and then 4.8, and then 2.8, and then 0.8, 0.2, 3.2, 5.2, 6.2, and 8.2. Oops. And 8.2. And now what we're going to do is we're going to add all those differences up. Okay, so when you add all that up, you're going to end up with 46 is what you should get. Now again, the count is nothing but how many numbers do I have? In this case, I have 10. So we're going to take that 46 and we're going to divide it by 10, which will then give us a mean absolute deviation of 4.6. And that's all there is to finding mean absolute deviation. There's 3 basic steps. Okay, step number 1, you're going to find the mean of your data. And that's what we were doing. We found the mean of our data, okay, and then wrote it all down. Okay, then we're going to find the positive distance or positive difference of each value from the mean. Okay, so we take each of our values and we do data minus mean, data minus mean, data minus mean. And whatever number you get, we're just going to take the positive version of that. Okay, and then to finish it out, you're then going to find the mean of all those differences. So you'll add the differences up and divide by, in this case, 10 again, because that's how many data points that we had. And that's all there is to finding mean absolute deviation. So what you're going to do for me, for your assignment, is you're going to practice this same exact thing. Before we do that, let's look at one little STAR question real quick. This is how they actually test you on STAR. Now, this is from an older test, but it's the same basic concept on each time you do this. It says the list shows the number of songs that 5 students each downloaded last week, 32, 43, 38, 28, 51. What's the mean absolute deviation of the numbers in the list? So that's what I'm looking for. Now, what you're going to do, what you'll find, is that they pick their answer choices in a certain way. So if we were to add all those numbers up, okay, the 32, 43, all those things right there, you're going to get a mean of 38.4. Now I want you to notice the answer choices. That mean is one of your answer choices because they know that whenever you're doing these problems, when you see mean, you don't read the rest of the problem. You just go ahead and go do the mean. And so they give you that as one of your answer choices. But you need to know, mean absolute deviation comes in 3 words, so that means there's 3 steps that we've got to follow, and you got to remember that. That's what we're doing. Okay, so in this particular one, you get 38.4. So any number that's close to that, you can also eliminate. So those numbers you can eliminate. So we know, now if we go through and do our differences, these 2 left answers, the B and the D, they're too close that you really have to actually do it. And you find out that the mean absolute deviation is 6.9, so the closest one to this one is actually B. But that's the way they always do these particular questions. And we'll work through them as we work through them in class to look at some of the tips and tricks that you can do on the STAR test with this. So what you're going to do for me today is you're going to do a little practice. You're going to do just a few questions. Okay, we've got 2 here and then 2 here, and all you're doing is finding the mean absolute deviation. And that's all we're going to do. So again, to find mean absolute deviation, there's 3 steps. Find the mean of all the data. Find the positive distance between the data point and the mean, and then find the mean of all those differences. So until next time, I'll talk to you later.